Hey everyone, welcome to today's Explainer. I'm going to be your site inspector today, walking you through the absolute must-know electrical hazards and life-saving protocols. Whether you're knee-deep in mud on a construction site or chilling in a climate-controlled office, this stuff totally applies to you. Electricity powers literally everything we do, right? But man, it is entirely unforgiving. So today, we're going to figure out exactly how to control it before it controls you.
Okay, let's just quickly run through our morning safety briefing agenda. We're going to hit the pre-shift checklist, compare field versus facility hazards, run a quick dead versus live drill, go over emergency rescue steps, look at some real-world case studies, and wrap it all up with a final quiz just to make sure we're totally aligned. Let's get to work. All right, kicking things off with Section 1, the pre-shift equipment safety checklist. This is literally the most practical, life-saving tool you've got in your back pocket. So here's the deal. Before you even think about pulling the trigger on a power tool, you've got to follow these 5 steps meticulously. Look for any cuts in the cable, stretched insulation, or crushed sections. Check the casing. If it's cracked, remember that thin plastic is literally the only thing standing between your bare hand and a lethal current. Make sure your hands are perfectly dry, because moisture just tanks your body's electrical resistance. Verify your RCD protection is good to go. And if anything at all fails this visual check, boom, remove that defective tool from service immediately. Now, step 4 just mentioned an RCD, or residual current device. And you might be wondering, why does that matter so much? Well, a standard circuit breaker protects the equipment itself from overcurrent, but an RCD, that protects you. It's constantly monitoring the balance of the current going out on the live wire and coming back on the neutral. If it detects even a tiny fraction of that current leaking to Earth, like, say, by traveling through your body, it trips in milliseconds, faster than a human heartbeat. It's an absolutely vital layer of protection, especially when we're dealing with wet areas or temporary power setups. All right, time for our first quick review. Say you pick up a drill and notice the casing is cracked, or maybe the cord is frayed and you can see the copper inside. What is your immediate action? Think about it for a second. Okay, you don't tape it up, right? And you definitely don't just toss it back on the shelf for the next poor guy. You stop using it instantly. You tag it out of service and you report it. Simple as that. Moving right along to Section 2, field and facility electrical hazards. Let's uncover some of those hidden dangers creeping around both of these environments. Take a look at this breakdown. It's pretty easy to spot the danger when you've got a massive crane operating right next to overhead power lines. Electricity can actually arc across that gap without the equipment even touching the wire. Crazy, right? Or when you're dealing with heavy generators and temporary site wiring. But listen, our office and warehouse staff, you're just as vulnerable. The silent killers indoors are those heavily overloaded power strips shoved under desks, frayed extension cords getting rolled over by office chairs, or faulty break room appliances slowly heating up through loose connections. Electricity really doesn't care if you're wearing steel-toe boots or business casual. Let's see if you've been paying attention to your environment. True or false, electrical hazards only pose a severe risk to workers on active outdoor construction sites. Well, as we literally just discovered together, that is absolutely false. A fire sparked by an overloaded socket in a quiet office break room can be just as devastating as a live wire out on the dirt. Okay, listen up, team. We are now entering Section 3. This is our simulated drill focusing on safe boundaries, dead versus live zones. Check out this stark contrast between these two environments. As a hard and fast rule, we always prefer to be in the dead work zone. That means the power is isolated, locked out, and zero energy has been actively verified. It's safe. On the flip side, the live work zone is a realm of extreme danger. It's a complete red zone, strictly off limits unless you're an authorized specialist rocking arc-rated PPE. Why? Because of arc blasts. That's a terrifying event where high current jumps through the air, releasing extreme heat, pressure waves, and flying metal fragments. Seriously, live work is never just a casual task. So how do we get to that perfectly safe dead work zone? You've got to execute these precise lockout/tagout, or LOTO, isolation steps without skipping a single one. First, you identify the energy source. Second, physically switch it off. Third, apply your personal lock and tag so nobody else can turn it back on. Fourth, verify the isolation by trying to start the equipment. And finally, test the circuit with an approved tester. Assuming a circuit is dead without actually testing it, yeah, that is exactly how fatalities happen. Let's lock this drill in with a quick review question. You've thrown the breaker, you've slapped your physical lock and warning tag on it. Fantastic. But what is the mandatory final step before your bare hands get anywhere near those wires? You must test before touch. Never ever trust a label or a switch position without verifying zero energy for yourself. Now, unfortunately, human errors do occur, so let's move to Section 4, Emergency Electrical Rescue Steps, where we'll cover exactly what to do during an active incident. I need you to focus intensely here because this sequence is literally a matter of life or death. The absolute most important rule is Step 1, do not touch the casualty directly. I know it goes against every human instinct to just stand back when a friend is hurting, but if you grab them, the electricity is just going to use you as the next path to complete its circuit to the earth. Suddenly, we've got 2 victims instead of 1. No way. You have to isolate the power source first. If you absolutely can't shut it off, and you're trained to do so, use a dry, non-conductive object, like a piece of dry wood, to separate them. Then, immediately call for emergency help and administer CPR once they're clear. Remember, every single shock victim needs a medical evaluation. Electrical burns often cause severe internal damage that you can't even see.
Quick review just to make sure this is burned into your memory. Why is it a fatal mistake to grab a coworker who's actively being electrocuted? Yep, because you instantly become part of the electrical circuit. You literally become the conductor. To really drive these protocols home, let's jump into Section 5, Real Incidents and Consequences. Let's see what happens when these hazards become a reality.
Take our first incident. Someone in a totally normal, seemingly safe office environment thought a standard power strip was no big deal, but they plugged a heavy draw heater into an adapter, which was then plugged into another power strip. You know, daisy chaining. Well, this created massive electrical resistance. And as we know from Ohm's law, high resistance generates intense heat. The connection just slowly cooked inside its plastic housing, sparked a fire, and boom, it rapidly gutted the entire facility, all because of a basic misuse of an extension lead. In our second case study, out in the field, a worker decided to skip their pre-shift checklist. They didn't verify their RCD protection, and they fired up a portable power tool in wet, muddy conditions. That moisture completely tanked their body's natural electrical resistance. So when a fault happened inside the tool, there was no RCD there to trip the circuit in milliseconds. The deadly current just took the path of least resistance right through their chest. It resulted in a massive, life-threatening shock.
So, based on those terrifying and very real incidents, here is your next review question. Let's say you're walking past an overloaded socket in the break room, or you spot a chewed-up extension cord being used by a completely different contracting team on site. Can you just walk on by and ignore it because, hey, it's not your job? Absolutely not. Safety is everyone's responsibility. You have to intervene. All right, you've made it through the walkthrough. Let's wrap things up with Section 6, our final safety protocol quiz. Let's see what you've retained today. Question number 1. What is the name of that essential protective device that acts in milliseconds to save your life if it detects current leaking through a person? It's especially critical in wet or temporary setups. Got it? That's right. It's the residual current device, or RCD.
Next up, question 2. In that absolutely crucial isolation procedure we talked about, what did the letters LOTO actually stand for? Lockout, tagout. Remember the steps. Identify, isolate, lock, tag, verify, and test. Now, I want you to memorize this mantra. It basically dictates our entire safety culture here. If you see a hazard, whether it's a frayed wire or an open electrical panel, you stop the work. You report the defect immediately, and you make absolutely sure the area is completely safe before anyone is allowed to continue. See it, stop it, report it, make it safe. I'm going to leave you with this final provocative thought. We've seen today how electricity operates silently, strikes faster than a heartbeat, and gives absolutely 0 second chances. Knowing that, knowing what's literally at stake for you and your whole team, are you ready to make the active choice to treat electricity with the ultimate respect it demands every single shift? I highly encourage you to review your specific site's safety handbook to learn more about your zone's unique hazards. Stay alert, stay protected, and have a very safe shift out there.